So there are 4 sessions. The first ones are calculus, and you'll see if you go from the next page through calculus, go to the next slide, and go to page 4, I think, you'll see something that says calculus, distance, speed, and acceleration. I don't know if you can see that on the 4th page. You see the way that's a slightly different type of slide. It's called a title slide in PowerPoint, where it's taken the center spot on the slide. That's another chapter in a way in calculus, okay? So, and then when we move to the end of that, there's only 2 chapters in this particular topic today. When you get to the next one, the next page, you'll see there it's called Equations and Inequalities. Mathematical one like that. So in Equations and Inequalities then, we've got a number of chapters in that session. And then other chapters in that session, okay? Now, the reason we talk about the chapters is it's a unit of understanding, I suppose, or a bit of the course where you say, that's where I think my issue is. So we're going to do 2 of those topics in calculus. We're going to do 3 or 4 in others as the hour and a half works. Is that okay? We won't cover the whole course today, okay? But we'll cover a chunk of it. And I hope that in each of the sessions, or in many of the sessions at least, that you say, I didn't see it quite like that before, or that's an interesting way to look at it, or whatever. Over the year, I'll be giving 2 sessions, I hope, in April in Dublin. We generally give a Saturday and a Sunday. We do 7 sessions, I think, over the 2 days. And because we have a college in Cork and Limerick, I give a day in Cork and a day in Limerick. And over the 4 days, I try to choose or make sure that I cover the whole course. So that the session on, obviously, day 1 and day 2 aren't the same, and the ones in Limerick and Cork aren't the same. Now, they overlap a bit. Max and Rory here video the lectures, so that for each of the sessions then in that chapter, from each of the areas, you can say, well, he didn't cover that for me because I wanted to look at the line again or the complex numbers because we're not doing that, but now I can look at the complex numbers from that session or that session. Is that okay? So that's the purpose of that. So I'll just show you briefly, if I can. This is a site. I'll turn to the computer for a minute. This is a site called Leaving Cert Maths. And I'm thankful that this lady here, Becca, has helped me put that site together. Becca actually did the course a number of years ago and actually now has graduated. And she's working in Dublin. But she's kindly come back here today and helped me out. But basically, what we're doing here is we put up Leaving Cert Maths. This is a site that we're still working on. It says LCM for Leaving Cert Maths under the tree and Ortecht Mata on the other side if you were doing it as Gaeilge. So you look there at Leaving Cert Maths. We do it in English for today. There is a day I do it as Gaeilge as well. And basically what you have here is you'll see that using a color-coded system, it's not very clear there, but hopefully it is. The green sessions there, numbers, complex numbers, tax and finance, are all in the number side of your syllabus. It's all done to Project Math syllabus. All of the 5 strands are there in each of the various themes. There's a theme there on equations and inequalities and a theme on geometry. The other topics then, you go to more topics. And on the more topics, you get to see calculus, functions, probability, statistics, and all of that. Okay, so that's the site. Now within the site then, there are 4 rows. So if we go to something like, say, and we also put in a bit of fun just for a bit of distraction. Now, you can choose things to submit to me if you think they're distracting or useful or whatever. There's the one as Gaeilge, if somebody wants it as Gaeilge. And if anybody is from a Gael school here, you can see that there's Ivrica and Feynman and Trí and Tánacht and the whole lot in there, okay? Where the sessions are as Gaeilge. Now, and a bit of crack as well there. Okay, so we go back then and say, let's go back to English. Under each of them, what we've done is, we've written the class notes. The class notes are exactly what you have in front of you now. The class notes are the notes I'm handing out for this session. So you've got sessions for four sessions today. The other ones then are videos, and that's the video of the class. This section here is a checklist, and the checklist is a list by list, line by line of the syllabus that says, in the line, I have to know the following. In algebra, I have to know the following. In graphs, I have to know the following. And then the last one is exam questions. And in the exam questions, what we do there is we've taken every single question in Project Maths papers and all the previous papers that still apply under Project Maths and said all the questions in complex numbers are there. All the questions on geometry are there. All the questions on probability are there. So rather than saying which year was that in and let's try the question from there, you can find them there. Okay? So I'll just show a video now. Maybe this is of geometry. The videos were done by Max, and some of them are on YouTube as slots, but generally what we try to do is we're changing the technology over one year to another. Here's constructions. We won't be doing those today, but you know the way you're meant to be able to draw certain things in geometry. And we've now jumped to the playlist. Here's the playlist, and you can see which of the constructions. Now there are constructions 16 to 21, calculate various things, and how do you do that? So you might say the in-center and in-circle of a circle, and you go to that one, and it wakes up here a little bit, and you play it. We turn now to construction 17, the in-center and in-circle of a given triangle, again using only straight edge and compass. So we're looking now about creating the circle that's inside A, B, and C with an in-circle here, in-center in the middle. What we do is we find the bisector of the angle. The lines are a little bit blanched there with the power of the screen, but on your computer you can see those quite clearly in black and white. Lines here. And you can move along to this, and then you'll see tabs. You say, okay, let's move the thing forward a bit. The equidistant notched point on CA. What we find is that they cross, and that intersection point there. So using the same equidistant. And as you can see, as I move the 2-minute thing along, as the thing buffers or whatever, as it plays there, you can just see that. Sorry, I paused it there, sorry. Once again, we have marked a notch there. So using the same equidistant notches, we take... And it goes on and does the various things. Is that okay? So the site is there for you to use. Now, for you to use the site, and the whole course, the purpose is to have the whole course. And we can construct now another construction line. And that's and then you see where the insert. And if you take it to the end, it's about there at the moment, buffering. Here, and take that distance there. Oh, it's paused again. Yeah. Just hit that. To the edge. To the edge. So we should be able to draw a circle, construct a circle. That reflects the inner circle of the three sides, A, B, and C. So the site, I just killed that then. So we have the point O, hearing myself twice, and the circle for construction 17. I'll kill that, and pause it, and there. So the site is called, I'll just go back to that, the site is called maths.gcd. And if you look at your yellow notes, if I'm not mistaken, on both the front and the back page of the yellow notes, there's a reference to that particular website. Is that okay? So just pop in there. Now, the first time you go in there, you have to sort of ask for a username, and then you're in. Is that okay? Now, it's 9:30. I'm going to start on calculus, but probably this part isn't going to be quite recorded just yet. Calculus is the one session today where we've only got 2 chapters. Okay? We'll cover the 2 chapters, and we'll probably start in about 10 minutes' time. But there are other parts of your course. Because of the way Project Maths has changed now, you need to know all of it, really. Years ago, a few years ago, you could do 6 out of 8 questions on paper 1 and 6 out of 8 on paper 2. And that was fine. The course was a little bit different. There were a few extra topics in it, but people had choice. With Project Maths, you know yourself, there's no choice. Every question can relate to every other question in every other part. And you sort of have to get a sense of just about everything. Is that okay? Because everything connects. And they can throw things at you a bit differently. Is that okay? Now, what we're going to do here is we're still going to take the topics, calculus as a topic, but in other areas of the course, we sort of showed the connections. Now, I didn't want to start and say, God, calculus was a bit dry. I thought that I'd show you from another topic. There's a topic called functions and graphs. Hopefully you can see that one there. functions and graphs. It's not on your notes, but it's a different topic where we show the relationship between functions and graphs in calculus. And I just thought I'd take a minute of that because people coming into the calculus would have that benefit, okay? And I just look at this one for a minute. Really what I wanted to do was to ask you today, does anybody know why you're doing calculus? And any idea what it's for? Or any idea really what it's about? Why are you doing calculus? Is it just because it's on the Leaving Cert, is it? Pretty much, is it? Well, I'm an engineer, okay? I love maths, right? I've always loved maths. But to be honest, calculus is about the most important bit of maths anywhere, ever. Okay? What it does is, and think about every single application, calculus tells you how something is changing. The rate of change of something. Is it getting better or worse? And let's look at this graph. I'm sure you've seen this graph a million times. A graph like that, a quadratic graph where you found the roots and all of that stuff. You know those ones, don't you? There's a graph. It's a quadratic. It crosses at 2 points. It crosses the y-axis. There's a point there. There's the intersections. You can solve the factors and all of that stuff. But this point here is a really interesting point because it's the lowest point. If you had a nice fancy vase at home and you rolled a marble on the inside of it, that's the point where the marble would stop. That is the only point in all of the graph where the slope is horizontal. It's the only point where it stops going down and starts going up. The only point in the whole graph where things are changed. Things have stopped going one way and gone the other way. Now, when do you ever use that? Just think for a second of any radio program you have heard for the last 2-3 years with the news. I'm not talking about MTV or anything like that. The economy is getting worse, worse, worse. It has turned. House properties have gone down, down, down. They have turned. Unemployment has gone up, up, up. It's turned. It has stopped going one way. It's got better. I'm putting on more and more and more and more weight. I'm losing weight. I'm losing weight. I'm putting on weight. I'm getting fitter. I'm not getting fitter. I'm getting older. Okay, that's a pity. Okay? But I'm getting healthier, fitter. I can run faster. That's the fastest I'll ever make the marathon. That's the point of turn. I'm turning a corner and I'm going into the next corner. When do I go from the one turn into another turn? Where's that point of inflection? Now look at the word most or least. How many times in the world do people think about the most or the least? The most is where it turns. The least is where it turns. The most expensive, the most profit, the least cost, the least hassle, the most gain. Anybody, anywhere, is using calculus for everything. The max you can load a bridge, the max you can pay for something, when people stop buying your product if you price it too high, how much did you charge for an iPhone, all of those things. Everybody's working on max min all the time. Is that okay? It is everywhere. Economists use it, engineers use it, fashion people use it, marketeers use it, all the time. What is the best you can do with that? Later on in the second part of calculus, we're going to be throwing up a ball or something to a height and coming down. What's the interesting point? When it's at its highest. When it stops going up and starts coming down. Is that important? It is for rockets. It is for Virgin as they fly across out of space. It's for everything. How far can you hit a ball? What's the best angle to hit a hurley ball at, a schlitzer at? Is it 45 degrees? Is it whatever? 30? Is it 60? Most, least, anything. So calculus is crawling everywhere. Is that okay? And it's very simple. Has unemployment rates for your age in 3 years' time, following college or now, changed? Yes. You can wake up most mornings and say, things are getting better. The job scene is getting better out there. It's not as bad as it was for my older brother, older sister 5 years ago. It has turned. Is that okay? So that's what calculus is. Now, what else is calculus is? Well, calculus is about how fast is it changing. As I go out 1 meter out here, only 1 step east, I go up 4 steps north. That's a pretty high ladder. For every step I go this way, I have to climb 4. Whereas here, 1 step here was only 1 step north. So that was a fairly small hill. But then the owl sort of, it turned into, K2 or something like that. You know what I mean? And then here it was easy because I was coming down, it was grand. Okay? Bank shares, house prices, all of the, how fast should you drive a car before it gets unstable? All of these things. It's everywhere. Is that okay? So before you look at calculus again, I just thought you should sort of know what all this stuff is about. The most costly, least costly, most efficient, least this. You're going to use least and most sometime in the next week on something. You'll want to know what's the best or the least or whatever. Okay? That's not to do it today because it's in a different chapter, and I just thought that I didn't want to go into calculus and say, oh, here's a chapter, it's out of somewhere, where's all this coming from, without giving you some reason as to why this is going on. Is that okay?